Hey everyone, this is Derek, and in this video we're going to look at solving exponential equations. So it has some pretty well-defined steps for doing this. So if we see an exponential, this is why we got logarithms, is they do find exponents. And so we're going to log both sides of the equation, and then we're going to bring the exponent down front using property 3, and then that's going to let us have something we can solve at again. So for here, let me just write this a little bit bigger. X to the 2x plus 3 equals 7. And I'm going to use natural logs because they take up less space. That's pretty much it. We'll also see a lot of base E stuff coming up, so I will probably just default to natural logs, but you can use log or natural log to do this. Won't make a difference. If you do see base E, you definitely want to use natural log though. So here I am, I'm logging both sides, and now I'm going to bring the exponent down front. So that gives me 2x plus 3 times natural log of 8 equals natural log of 7. So then here's the thing, natural log of 8, that is just a number. So we're just going to divide that over. Like if this was 2x plus 3 times 5, I could divide both sides by 5. So that's all I'm doing here. And then this is where you want the calculator to do most of the work. And so let me bust out a calculator. So we're just going to go natural log of 7 and then divide that by natural log of 8. And then I made that a number. And so now I have this number that I'm not going to write down. I'm just thinking of it as the number. And then the next thing I would do is subtract 3, right? So on the calculator, I'm just going to go, okay, cool, minus 3. And I'm letting it keep track of all those decimals for me. Cool, so now that's done. And then the next thing I do is divide 2. Okay, so again, having it do it for me, so divide by 2. And then there's my answer. So I got x equals negative 1.032 to 3 decimal places. Okay, so for number 2, when we have that 6 out front, we do not want to log both sides because now I have something that is multiplying, and I can't bring the exponent down front without separating those, and that's a bummer. But what I can do right now is just divide the 6, and then I'm solid. So I'm going to divide that 6 over. That's going to give me 0.4x. This is not a nice number. It just kind of keeps going. And so I am just going to kind of refer to it as 11/6. And then I will, again, I'm going to use natural log, but you could totally use log. X down front. And then that just equals the natural log of this number. And then now I'm just dividing over the 0.04, or the natural log of. And toss it in the calculator. I got negative 0.662 when I did it. Okay, this example also has a few little steps to do before we want to log both sides. So first thing I'll do is just add the 4 over because I'm trying to isolate the log. So that would be 8e to the x equals 24. And then now I still have that 8 out front, but I can divide that over just like the last example. Cool. So that gives me e to the x equals 8. I'm going to log both sides and go through the steps and then do the shortcut afterwards. So here, if I natural log both sides of this, I bring the x down front. And remember back a couple of videos, natural log of e, that's 1. So that's why we always want to use a natural log if there's a base e, because that piece drops out. And then my answer is natural log of 8, which is about 1.099. But something else I could have done from right here, e to the x equals 8. If I just think of switching this into exponential form, and this is true for any of these, other than you'd have to you'd need to change the base formula, and I was sort of avoiding showing that, so that's why I'm showing it logging both sides. But if I just rewrite this as natural log, right, because that's like our base e, of 8 equals x, there I am at the answer. So I can also use that change of form once I have it simplified. Okay, so then this one, suppose the population of a small city is 36,000 at the beginning of 2006, and the city council assumes population 2 years later, it could be estimated by that equation. In what year will the city have a population of 68,000? So basically we have the 36,000, so there's that initial value. It looks like, this one has an E in it, so we're gonna see that it's growing by 9% when we get into the application problems in the next chapter. So what year will the city have a population of 68,000? That's like our output. So we're gonna have 68,000 equals 36000 e to the 0.09 t. So first thing I want to do is get rid of that 36,000 because we never want stuff kind of around the exponential. That lets me cross out all that. If you throw that in a calculator, it's going to come out 1.88888888 forever. And just to make it easier to write, I'm going to write that decimal form, but I am not putting 1.8 in the calculator. I have that whole, when I do the math, I have that whole number showing, and that's what I would be working with, but this is faster to write. So now that I got that isolated, now I'm going to natural log both sides, and that allows me to bring the exponent down front. So natural log of 1.8 with a bar equals 0.09t, and that would be times ln, but remember that equals 1, so it's gone, and now I just have to divide over that 0.09, and that's going to be my time. So when I did that, I got 7.06, so that would be a little ways into 7 years after 2006. So with 7, that would be 2013. And I always get the question, wouldn't it round up to 14? And it's like, no, that's just 600ths of the way. So this would be like early January of 2013 is what that would be.